This conference will now be recorded.
Good afternoon, everybody. So today we will talk about the introduction to GIS. I'll share my PPTs with you all. Okay, so I think it is visible to everybody. Maybe you can say yes. Anybody? Okay, fine. Good. Thank you so much. So I'll switch off my camera so that there is no issue related to bandwidth. So once again, welcome to the GIS module, that is Introduction to GIS. I think this word might be familiar to you all because the applications which are derived by making use of GIS is enormous, and people are trying to make use of so many innovative areas where they can use this technology. So I will focus mostly on the GIS part, and then what are the basics of GIS. And in fact, the outline of my lecture covers geospatial technology. Then we will I'll discuss about GIS, what is the meaning of GIS, what are its characteristics, and then the how you can model different type of geographic phenomena. Then we will talk about the data models, specifically on the spatial data models. Then we will touch upon the topology and so many the relationships which are being used for querying the databases, and then few concepts of data types and values, and then spatial data analysis, and in the end we will talk about the applications of GIS. So I will not touch in detail related to the applications. Maybe only one slide I will try to touch upon that how GIS is being used in various applications, whether you talk about governance application or health. There are so many other areas. So now coming to the first important technology, that is the geospatial technology. I think geospatial technology is a core area now, and in fact it is considered as one of the important pillars in the development of any country. Because when I talk about geospatial technology as a whole, it consists of various components, like for instance the Earth observation system. I think in the previous lectures you might have understood the significance of the Earth observation data. This Earth observation data primarily consists of satellite data, and we have plethora of satellites revolving around Earth, whether it is in polar orbit or they are in geostationary orbit. From all the satellites, a lot of information is coming, and we really have to make use of that information. The information which comes to Earth observation data has different type of resolutions. You might have already studied that the resolutions with respect to spatial resolution, with respect to temporal resolution, with respect to radiometric resolution, with respect to spectral resolution. There are so many different types of resolutions available, and it is not that it is confined by a particular agency which is providing. In fact, there are agencies, global agencies, whether you talk about agencies from US or from European Space Agency, or let us say India. So everybody is providing different type of satellites, which is being used by many users, irrespective of their country specific. So these satellite data is being used by n number of people, and because of so many different type of resolution, the coverage of a particular area becomes quite feasible. In fact, it's not only the government agencies. There are commercial or private entrepreneurs who are also providing support in getting good spatial data, the Earth observation data. So now, because of this different resolutions available, you have good access to these data sets. And important part is, it's not that you are getting the actual satellite data of a particular band. Even you are getting the geophysical products from these. So these are all derived products from the remote sensing data, and which you can directly use in your application. So if you see geospatial technology as a whole, Earth observation plays a very important role. And in fact, it's not the satellite sensors which are on those space-based platform. You can capture these data from the UAVs or drones which are there, and even the cameras can be mounted on aircraft. So there are different ways and means to get these sensor data, and you can use those data sets for your applications. Uh, Another part of the geospatial technology, I will come to GIS in the later stage. The second pillar of geospatial technology is anyway GPS, or let us say GNSS, which provides you the locational information, which can help you to get a real time, I would say a real time position of a given object, and also it helps you to develop some navigation tools. So GPS, I think, with the availability of the smartphones available all across the globe, people can geotag any of the data or any photographs or anything. And because of this, the locational information, the position of that particular object can be tracked by making use of the different type of GPS, or there are so many other agencies who are providing the locational information with the help of the constellation of satellites. Uh, then I will come to GIS. I think GIS has an important role to play in the geospatial technology. The important part of GIS is it takes all the data coming through Earth observation, the data which is coming through GNSS, even the data which is coming from the field sensors. So you might have some sensors which are installed in the field in order to validate your products, or even you can think of a data which is coming through a crowdsourcing mechanism where you have the location information and also you are taking the snapshot of that area. So all these things which are having a geospatial coordinates can directly be integrated into GIS, and it can be presented in the form of a map which gives a lot of information to a user who is looking for. So basically, it has a mechanism to integrate all the geospatial data which is coming from various sources, and ultimately you can model them together and you can derive meaningful information which you are looking for. The second last part is the ground data. I was telling you that the ground data provides a lot of valuable information, because anything what you collect through a satellite or what you collect through so many other sources, you need the ground information. So this ground information might be having the attribute information, or even there could be a possibility of the information which relates to some in situ observations, or I told you that there could be a citizen centric application like a crowdsourcing or public this voluntarily geographic information. There are different things which comes from the ground and can directly be integrated and is a part of a bigger umbrella of geospatial technology. The last but not the least, the ICT, information and communication technology, ultimately really helps you to disseminate your data. So whatever the communication technology, it basically it helps you to transmit the data from one place to another. So ICT plays a very important role, and if you have a good bandwidth available, you can really make use of these applications in a more meaningful way. And ultimately, whenever there is a requirement of the data is available with the help of ICT. So all these technologies together encompasses the geospatial technology, which is an important area. So when we talk about GIS as a whole, I think just to give you a brief history of GIS, GIS is a technology which primarily helps you to create the data which has got a geospatial information. So basically, you will be wondering that how old it is. In fact, let me tell you, the concept of GIS evolved way back in 1854 by Dr. John Snow, who was basically an epidemiologist, and he happened to create a map of the cholera outbreak which happened in London. So at that time, what he did is he prepared the maps of the death which occurred because of cholera, as well as the different locations where people were, like, there was a problem because of the water pump, because of the water quality, because of the some problem because of the water quality, these incidents took place. So in fact, there was a because of the cholera epidemic or outbreak, let us say, or epidemic, basically they were unable to understand whether this is because of water quality or this was because of air quality. And in fact, what he did is he created the maps of the locations where those water pumps were installed and the death. And then he related with this. And once he related, he could identify a water pump which was basically providing the poisonous, or I would say the infected water quality. And because of this, the moment they removed this water pump, they could they could easily the death toll was drastically decreased. So that was a concept of the GIS at that time. And in fact, in order to develop the geographical information system as a software, this was evolved in 1960 by Canadian Geographical Information System, and from there it started migrating into the commercial system, and from there those different applications was developed, and it was being used by municipality and so many other governance applications. So that was the beginning of GIS. And in fact, from then, I would say from 1960 to 2020, there is enormous evolution which has taken place in this technology. So basically, GIS is a computer-based system, or I would say it is one of the software which provides following four sets of capabilities to handle just georeference data. Because when I talk about georeference data, because anything which has got a geospatial coordinates ultimately correspond to the GIS, means that the GIS software can help you to create the data. That is, it can help you to input the data, it can help you to manage the data, it can help you to manipulate those data sets, and ultimately it can provide you better maps which can ultimately give meaningful results, or it can be used for various decision making. So these are the functional modules of GIS: data inputting. From data inputting, it goes into the databases, and from databases, once the data is organized, it goes for query and analysis, and from there query analysis you can generate an output, and ultimately these outputs can be used for visualization as well as for decision making. Now, if you look at the overall concepts, or I would say what GIS does is basically, as I told you, that it is a software which allows you to capture, to store, to manipulate, to retrieve, as well as to display georeferenced information. So basically, anything which has got a geospatial coordinates, means latitude and longitude, can directly be stored into GIS. So that is the most important part, because the primitive unit of GIS is a geospatial data, means the data which corresponds to latitude and longitude. So basically, any GIS software will have tools in it. It allows you to capture the data, it allows you to manage the data, and ultimately it allows you to do analysis and can give you an output. The another component of GIS is a database definition, because database is one of the most important component of GIS. I would say it is considered to be one of the backbone of GIS, because what it does is, because you are dealing with so much data which has got geospatial coordinates, and you have to store them in a way by which you can retrieve those data at any point of time. So basically, the most important part in this particular GIS is that it qualifies a database system in which most of the data are spatially indexed, means because whenever you want to retrieve these data from so many number of polygons or so many number of grids, you really have to make use of the indexing technique, which is one of the technique in the databases to retrieve the data. So basically, database is an important component, and you need a stronger database at the back end so that you are able to retrieve the data at any point of time. The last is the decision support system. So basically, if you are developing a GIS tool for given application, you can develop a decision support system, and GIS allows you to have the tools you can customize as per the requirement, and those type of tools can directly be used for different problem solving applications. Now, coming to there are two types of data available in GIS. One is the spatial data, another one is the non-spatial data. The spatial data, basically, as I was telling you, that it corresponds to the features, orientation, shape, size, and structure. Means if I talk about a polygon, the polygon extent will be the spatial data. If I am talking about point location, means the latitude longitude of that particular point will be considered as a spatial data. If I talk about line, then the extent of this line will be the spatial data, where you have the location information. So basically, spatial data corresponds to the locational information of that particular area. And another part of the GIS is non-spatial data. The non-spatial data basically corresponds to the information, the qualitative information of that point, line, polygon. Means if I'm having a spatial information of a particular point, then I should also know that what that point correspond to. Does it correspond to a well location? Does it correspond to a weather information? So ultimately, I can attach infinite number of attributes for a given spatial data. So that is the beauty of the spatial data, which makes it unique in total. So now the most important part is the geospatial data. So geospatial data, I was telling you that it corresponds to the spatial and non-spatial data. So basically, geospatial data, let us talk about this tree's location, where it is located, is the geometry, or let us say it talks about the location of that particular tree, means its latitude and longitude, and the characteristics of that feature will be the non-spatial information, where you talk about all the qualitative attributes of that given data. So you have, when you talk about geospatial data as a whole, you talk about geometry, you talk about its location, and you also talk about its characteristics. So basically you are trying to link the spatial and non-spatial data and providing more information. So like for instance, if I talk about tree, the spatial data will be its location, its geometry, where it is located, and the second part will be the characteristics, where you talk about the type of tree, age of tree, height of tree, biomass. So many things can directly be linked to a geospatial data. So this is one of the most important component of GIS, where the data, the geospatial data corresponds to that information. So basically, if I talk about different characteristics of spatial data, so you are more concerned that when you have a GIS map, you always talk about the spatial reference, means where it is located, what is that map, what quality attributes it provides, how it is related to other objects, and when it is going to change. So all these different characteristics of the spatial data is taken care in a given GIS map. So there could be different sources of input data. There are you can take input from Earth observation, that is, you can take either from remote sensing, photogrammetry, you can take from hard copy maps, you can take from GNSS, you can take inputs from total station, and it's not, you are not limited to these. Anything which has got a geospatial coordinates can directly be integrated into GIS. So basically GIS is a much bigger umbrella as compared to other domains. So basically it integrates all the data together, and it helps you to analyze them, and you can generate different type of outputs. Now if you look at the overall why we really needs the data models to create those data and model them in a GIS domain. The important part of the GIS is that it allows you to model the geographic phenomena. So when I talk about geographic phenomena, whether you talk about anything, like let us talk about the elevation or temperature, so many different type of phenomena which are available in the real world. So basically, any geographical phenomena has to be named. It should have the location. It should have the attributes, and also at which the time component is also important. So it will be difficult if you remove any of those components in the geographic phenomena. It is really difficult to model it. So basically, if you look at the different types of phenomena as a whole, you have to write, suppose if you want to capture the elevation of a given area, or let us say you want to capture the land use of a given area. So you really have to make use of the GIS models to whether how I can store these data sets in the computer domain. So for that, there are different types of geographic phenomena which are observed. Some phenomena are field based and some are object based. The field based phenomena are those phenomena where you have the basically you don't have boundaries. Rather, I would say that it is slow and gradual. Let us talk about the elevation. You have the elevation changes slowly. It doesn't abrupt. There is no abrupt change in the change values. So basically, or even you can talk about temperature. So these geographic phenomena, if you really want to model them, they come under the major category of fields, or let us say continuous phenomena. But there are few phenomena, like let us say if I want to create a building, the land use map of very high resolution, or let us say you want to create the vegetation type map. So those type of phenomena where you have the boundaries already identified, they comes under the object based phenomena. So these two types of phenomena are they correspond to all type of geographic phenomena which is happening in the real world. So these field based phenomena can be captured by making use of continuous field, and the object based phenomena where you have the identified boundaries they comes under the discrete phenomena. So continuous phenomena, where you know that there is a slow and gradual change and you don't have a defined boundary, whereas the object based or discrete bit phenomena, they have the identified boundaries and the value in those objects is always same. So you can see that the from the continuous you can even migrate to the discrete phenomena, but it all depends upon the type of application you are looking for. So you can see that these geographic phenomena can be mapped by making use of field-based or object-based, which basically talks about the continuous as well as the discrete phenomena. So now once you know that these phenomena are continuous in nature or they are discrete in nature, so you have to decide which type of data model you should use in order to map these information. So basically these are the two approaches which is being used. One is called the raster model, another one is called the vector model. So you can see this is the real world, and in the real world these two models, basically the vector, another one model is called as the raster model, another model is called as a vector model. So these two models are being used to store the data in a computer so that you can further do modeling and derive the information available. So you can see that this real world can be represented as a vector where you can see good number of polygons, and rather it talks about more discrete information where you can see it is more of a the object based phenomena which is happening. And a similar thing, if you want to model it by making use of raster model, you can see that they are being represented as continuous phenomena, and where you can see that there is a slow and gradual change in the grids. The raster model basically helps you to represent the continuous phenomena, whereas the vector model is being used for or it is being used to represent the object-based phenomena. Now, these two models are totally different in nature, and they have the raster data model. Basically, you can see that it is having a different data structure. Raster data model, as I told you, it represents the continuous phenomena. It represents the continuous information. So you can see that these are always represented in rows and columns. So you can see first row, first column be like this. So basically, you are storing the data in the form of a cell, grid, or a pixel. But when you talk about vector model, vector basically talks about the object-based phenomena where you are storing the point, line, or a polygon where the value is same. All like if I talk about a polygon, any value within this polygon will be same. So basically, this is more of an object-based. It caters to the object-based phenomena. And here you can see that you are storing the data in the form of point, line, and polygon, where you can see that there are so many coordinate pairs. Basically, here you are storing the data in the coordinate pair and with a label. So you can see that point, line, polygon basically talks about coordinate pairs. Yes. Yeah. Any question? Okay. So basically here you are storing the data in the form of point, line, and polygon. So now here you can see that how we are storing this data. So as I told you that the vector data model basically talks about the coordinate pair, and you can see that A, B, C. A is a point, B is line, and C is polygon. So you can see that the point is being stored as a coordinate pair. B is the line where you have a series of coordinate pairs, and when you talk about C, it is a polygon where you have the starting coordinate pair and the ending coordinate pair is same, means that it is a closed polygon. So this is the way you store the vector data model, where the XY coordinates are stored along with label. So once you have the data available, you can prepare different type of layers. Either it is raster layer or a vector layer. So every layer has to be prepared differently, and when you want to overlay them together, either you overlay all the vector layers together or the raster. You cannot overlay vector and raster together because the data models are different, their analysis are different, and their storage and their performance, everything is totally different. So because of this GIS capability, you can create n number of data, you can create n number of layers, and once the layers are created, you can overlay them together and generate new output. So that is the advantage of using the all these raster as well as vector layers. Another important part of GIS is especially the vector data model is topology, because topology basically helps you to maintain the integrity of the data. Because if you don't build a topology of a given vector data, then there is a possibility that there might be errors in the data. So basically there are three spatial relationships which is retrieved in a topological, or let us say vector topological model. Means there are three relationships, means area, the contiguity, and the connectivity. If you ensure that all the three spatial relationships, because you talk about area, if it is a closed polygon, it will be in an area. When you talk about contiguity, means what is on the left hand side, means the neighborhood relationships, and the connectivity, if you are talking about a line topology, the starting node and the ending node. If you have all these three relationships available or intact with you, then the topological model is ensured. And once the topological model is built for a vector data, then it is possible for you to apply any type of transformation to the topological model. So the important part of topology is it builds the integrity of the data correctness will be there, and once the topology is built, you can use it for any application. So topological model provides a lot of information. Now here you can see that there are different type of spatial relationships. In fact, whenever you fire a spatial query in GIS, you try to make use of these different spatial relationships which are available: meet, equal, inside, disjoint. There are so many 8 relationships which allows you to query any two data sets. So once you apply these type of relationships, you can retrieve the information from a large number of polygons. So that is the beauty of making use of these relationships which are available in most of the softwares. Now you can see that there are different type of overlay operations which you apply on the data. Either it is a vector-based operation or a raster-based operation. So you can see that the map overlay, as I told you, that raster and vector both are totally different because of the data structure, because of their storage, because of the so many reasons. They both have different overlaying operations. So you can see that raster has a different overlay operation, vector has got a different overlay operations. So this is an example of the vector overlay. Here you can see that there are 2 layers. If you have created those layers and you ensure that you have made the topological model, means the data correctness is ensured. Once the data is corrected by making use of topology, once the topology is achieved, you are able to overlay them together. So you can see that map A intersects with map B, then you are able to see that there will be more number of polygons because this map is on top of it. And since you have so all these polygons are there, you not only have the attributes of map A, but also you will have attributes of map B. So that is the important part of the overlay operations which happens on the vector data. So it has got the advantages of getting all the spatial features of both the maps together, and then it also provides the both the attributes. So this is an example of the raster overlay. The raster overlay basically talks about, as I told you, that it represents more of a continuous phenomena. So it governs mainly with the grid data or a cell or a pixel value, and any value in the cell can directly be manipulated by making use of any type of arithmetic operation. So you cannot do arithmetic operation on the vector. Rather, you will apply arithmetic operation on the raster data. So you can see that you can apply any arithmetic operation, you can apply any relational or logical operator, you can apply any type of conditional statements, and any combination of all this. So you can have, like you might have seen in digital image processing, where you apply those arithmetic. So that is more similar to the raster layer operation, where you are applying any type of mathematical formula to these data sets, and you can retrieve. Like there is an example of map C is equal to map A plus any numeric any addition you want to do, or you want to apply any the mathematical operation on two maps, or you can have different type of Boolean or logical operators can directly be applied on the raster data. So in both raster and vector, the analysis is totally different, and it all depends upon the requirement. So when I say all these things, there is a difference between the raster model and the vector model, and you have to be doubly sure that how you are going to create those data sets. So basically, as I told you, that raster data model is more of it represents more of continuous data structure, whereas vector talks about the object-based model. So the raster model is considered to be a simple data structure because you are storing the data in the form of rows and columns. But when you talk about vector data structure, here you are talking about the complex structure, because you are dealing with coordinate pairs, and it's not only the coordinate pairs, you are also making or applying a topological operations on those data sets. So it is more of a complex model as compared to the raster model. In the raster, you can easily and efficiently overlay the maps. You can apply any type of mathematical operations, but in vector you cannot apply a mathematical operation. Rather, you can overlay them together, and you can because once you overlay them together, you have to rebuild the topology, and once the topology is rebuilt, you can really apply those operations. But the overlaying operation in vector, because of the complexity, is rather difficult. Raster model is compatible with remote sensing imagery, like digital image processing is a classic example, but vector data model is not compatible with remote sensing imagery. High spatial variability is efficiently represented in raster, but that doesn't happen in the vector. In vector, it is inefficient representation of high, because here the individual polygons represents the same value. But here, up to the pixel level in raster, up to the pixel level, you are able to get the information, and you can provide those data sets to them. So the raster data model is simple for programming by user. It is simple for applying any type of operations, but here you don't have that flexibility. Raster data model is inefficient use of computer storage, because you are storing individual pixels. So we generally used to say raster is vaster but is faster. Means you have so many grids, so many pixels are there, and in fact, because of these enormous pixels, you are storing the data together. So that is you are taking more memory space in order to store those data. But that doesn't happen with vector. The storage, it takes very less space because of its compact data structure. There are errors in perimeter and shape. There are errors in the raster data model, because here you are storing the data in the form of pixels, and since pixels, if you are making use of different size of pixels, like there might be a map with less pixel size, there might be a map with a bigger pixel size, then there might be a possibility of errors in perimeter and shape. So those type of issues comes with the raster data, which never happens with the vector data model. You can apply the networking analysis on the vector data, because I told you one of the important property of a vector model is the connectivity, means the starting node and the ending node. So that connectivity topological model makes the networking analysis possible. Networking analysis, when if I try to give you more detailed information, means any type of optimization, like for instance, moving from one, like you might be aware about the Google Maps, where people are making use of navigations, the routing from one point to another. So this is the networking analysis, where you can get the the optimum route from one point to another by making use of the different type of resistance or impedances given to the different nodes. So those type of analysis can be done on the vector data model. It cannot be done on the raster data model. So the important thing is there is loss of information when you use large pixel size. In fact, yes, if you use a smaller pixel size, there will more the information can be retrieved and you don't have the loss of information. The raster maps are not appealing because of the pixelated effect, but vector are highly accurate and more appealing outputs. So that is the difference between the raster and the vector data model. Now I will come to the data types and values. This is an important component because whatever maps you create, ultimately you have to provide the different the legends or what type of information you are trying to visualize to the user. So there are two types of data types and values in GIS. One is a qualitative data type values, another one is a numeric data values, or let us say quantitative data values. So when I talk about qualitative data values, there are two subcategories in the qualitative data. One is the nominal or a categorical data, where basically you talks about different different data categories, whether you talk about land use, whether you talk about soil type, whether you talk about forest type, so many different type of categories you are trying to define. So that is a nominal categorical value. The second is the ordinal, where basically you are trying to give the ranking, means high, medium, low. That way you are storing the data. So these are the two categories which corresponds to the qualitative information of the data. The second category is the quantitative data or numeric data, where you are trying to show the actual data, actual values. So there are two subcategories in the quantitative or the numeric data. One is the interval data, where basically you talks about the values which is defined in the interval, means you have, let us say, elevation is from, let us say, 100 meter to 200 meter, 200 meter to 300. So that way you can give the intervals between the values, means the entire polygon correspond to these values. So basically you are trying to show some level of information to the user so that he can use those the values for further analysis. The another category of the numeric or quantitative data is the ratio, where you are trying to give the absolute value of that particular data, whether you talk about population density, or let us say talk about the temperature data, or let us talk about some like, let us say, rainfall. So these type of, where you are trying to give the absolute values, that comes under the ratio data. So so you can see that these are the two major categories, qualitative and quantitative. Qualitative corresponds to nominal or categorical or ordinal. Numeric or quantitative corresponds to interval as well as the ratio data. So you can see that there are various examples. I will show you this is a classic example of the nominal or a categorical data, where you are providing the categories of that information. So land use, land cover, or let us say forest type, or let us say soil type. This corresponds to the nominal or a categorical value. Similarly, you can have the mix of information, like for instance, you not only have the nominal and categorical, but also you can have the clusters which can be represented. You can see high clusters and low cluster, which corresponds to some level of the different number of species available. So this also comes on the quantitative assessment, where you are combining the numeric data, you are combining the numeric data with the qualitative data. So this type of scenarios could be there. I think you might be aware about the COVID-19, the pandemic which everybody is experiencing. And in fact, there was initiative by John Hopkins. They came out with a dashboard which basically provide the information, the spatial dashboard, I would say a GIS enabled dashboard, which not only provides the information about the different incidents. You can see the different type of clusters in different areas, and also country wise information. All that dashboard visualization is available. So these are the different ways and means to depict the data in a GIS domain. So maybe I think this is the outdated map. You can have a look to you can directly visit to this URL, and you can see the updated information with respect to global cases, with respect to country-wise cases, and how the death rate, recovery, everything is happening. So similarly, you can have the earthquake magnitudes. You can depict this data by with the help of the different magnitude. You can see the higher magnitude can be represented as a bigger cluster, lower magnitude can be represented as a smaller cluster. Similarly, here I'm trying to depict the intervals with the percentage values. So the population from age 5 to 17. So this way you can create these type of maps, and ultimately once you these values depict. So it all depends upon whether you want to show the quantitative assessment or you want to show the qualitative. It all depends upon the type of information you want to provide. So now coming to the spatial analysis. So there are, as I told you, the vector and raster both have different analytical capabilities. Why? Because of the different type of data structures. Now, if I talk about vector-based analysis, you have so many different operations which are available in any of those the vector based, like map overlay. You can directly apply the different type of operators, overlay operator like union, intersection. So many other operations are there. You can do the map manipulation, you can dissolve, you can clip, you can extract. All these are vector based operations. Another important thing is the vector based analysis also provide you a proximity analysis. Means suppose you want to create the buffer of uniform area, you can, if you want to create a buffer on both the sides or single side, multiple buffers can be created. So this proximity function is a good function, because suppose you want to use only restricted area for the analysis, so you can apply the proximity analysis, and ultimately it can only narrow down to that area where which like the buffer area where you want to do the analysis. Similarly, you have pattern analysis, the nearest neighbor spatial autocorrelation. You can work on the geostatistics. So all these pattern analysis can be carried out by making use of vector based. So similarly, you have networking analysis. I was talking about the transportation, I was talking about the optimal routing. All these things, or shortest route, you can directly do it by vector based analysis. But when you talk about raster based analysis, these are totally different, because you are dealing with a different type of data. The most important thing is the functions. You might have studied some of these functions in your digital image processing lecture, where you let us talk about the functions first. Local, focal, zonal, and global operations. These operations basically primarily works either on a pixel to pixel, that is local. When you talk about focal, means you are defining a kernel size, whether it is about 3 by 3, 5 by 5, 7 by 7, 9 by 9. Any type of focal operations you want to apply, you can directly apply on the raster data. You can apply a zonal operation, means only in a defined area or in a given category you want to apply this operation, you can directly do a zonal operation. And the global means you are applying entire operations on the entire image. So these type of functions one can directly apply, and you can directly make use of these functions. Then you have map algebra. As I told you, that these type of operations, arithmetic operations, trigonometric operations, all mathematical operations can directly be applied on the raster data. And now, because of their capability to apply any type of algebraic operation, they can do terrain analysis. Terrain analysis is also one of the important application, where you make use of the digital elevation model and try to derive the first order derivatives on those data sets, whether it is slope, aspect, contour, everything you can directly apply on those terrain analysis. Then there are hydrological analysis, the flow direction, flow accumulation, all these different type of operations can directly be done on the raster data. And the last part is the reclassification. You can also apply any type of reclassification to these data sets. So there are different functions for both the data sets. It all depends upon what is your objective, what applications you are looking for. And once you understand those applications, you can really apply those things. So basically, GIS can answer many questions. It can answer the location query. It can answer a conditional query, like for instance, I want to see those areas where the size, the forest size, let us say I want to see those forest areas where size is more than 200 square kilometers. So you can apply a condition. So all these operations either can be taken care by an SQL query, which is inherited, or I would say it's a part of the database which is enabled in GIS. But you can also fire a spatial query where you can make use of the spatial relationships. You can even make use of the trends, what has changed since swimming. You can apply a mathematical model. You can apply you can understand the change matrix, and according to it, you can have the understanding that how these type of information can be retrieved. There are pattern analysis, what spatial pattern exists. So this is also important, because this spatial pattern basically helps you to understand, like for instance, temperature interpolation, or let us say the dispersion modeling. All these things comes under the pattern analysis. You can apply any type of geospatial, or I would say geostatistical analysis. So all those things, pattern analysis, can be carried out on these data sets. Last is the modeling, means what if scenarios can be retrieved. Like for instance, you are going for predictive analysis, or let us say you are talking about the different type of stochastic phenomena. So all these modeling can directly be, whether it is empirical based, non-empirical based, deterministic, all type of models can directly be applied by making use of GIS. So it can answer many questions. What is the nearest area to a particular place? What are you can even make use of multi-criteria analysis to identify the new suitable sites. You can apply the modeling. Simulations can be done by making use of all these methods, which are either available in raster data, or it is available in the vector. Simple query, spatial query, single layer, multi-layer, all these different type of operations can be applied in GIS. And because of all these the analysis, or because of these capabilities, it is possible to really come out with some new innovative information which you are looking for. There are not only the commercial softwares which are available, like you might be aware about ESRI software, RJ, GIS. You might be aware about so many other COD software. But there are softwares available in the open source domain, like Quantum GIS. QGIS is one of the famous software, and it is not only QGIS. You have other softwares also which provides you the GIS functionality. So you are not limited to the CODS option. You can opt for the open source, and the open source software is not only available in GIS. You have the open source software is available in databases. You have open source applications available under mobile applications, 3D visualizations, modeling. Everywhere you have so many softwares available under FAST4G, means free and open source, and it can help you to really perform any type of GIS exercise on these software. So basically, they are quite user friendly. You really don't have to code much. Only thing is, whatever you are doing, you know, it is not black box to you. In fact, you know each and every operation by making use of the open source softwares. So there are many applications of GIS. In fact, there are, you can, I think from the very beginning, people are making use in natural resources, in disaster related projects, land use planning, infrastructure. But now there is a drastic change in the GIS applications. People are trying to see that how the health, like for instance, COVID-19 is one of the biggest pandemic of the century. And in fact, people have really make use of GIS, or let us say geospatial technology, to understand the disease, to come out with some remedial measures, and even counter, or let us say it can help you to relate with so many other variables which can provide you some hidden information which you are looking for. So health GIS, or let us say geohealth, is one of the the challenging area where this particular technology can be used. Tourism is also one area. Supply chain management, that is also a new area where GIS can be used. So, and of course, the governance application. So the scope is tremendous, and you only have to think that in what way you want to use GIS, and ultimately it can provide you some innovative solutions which can ultimately help you in decision making. Now, if you see down the line, the emphasis of GIS is a little bit changing, because the you are in fact, most of the countries have already created enormous amount of GIS data. The first hand information is available. Now they are trying to put more emphasis on the analysis, or let us say analytics, because the whatever data you have, you can try to extract the hidden information which can come out with the help of analysis, or let us say analytics. So these type of the present and the future, the emphasis will be more on the data analytics, because of the so much algorithms which are coming under machine learning or deep learning algorithms. And even you have big data concepts where you are trying to make use of so many different type of systems like Hadoop or MapReduce. There are different type of system which allows you to integrate different types of data. So GIS is not confined to only the geospatial, but it can even take the data from other domains, but should have a geospatial coordinates. So the emphasis is more on the analysis rather on creating the data. So in the end, I would like to mention that there is the saying by Jack Dangermond that the application of GIS is limited only by the imagination of those who use it. So with this, I complete my lecture. So maybe we can have quick questions from each one of you. So can we have questions? Uh, if you have any questions, maybe you can. Have you understood the lecture? I think yes. Okay. Okay. So is there any question from anybody? Okay. So I think people have understood. So my only request to each one of you is that try to read more about GIS, and because whatever I have taught you, it will be easy for you to understand in a better way. So thank you very much, and all the best to you. In coming days, you will be hearing in detail about the individual components which I have told you in brief. So it will be quite interesting for you. Okay. Thank you, and all the best to you all. Take care.